Okay, we are officially live. So this is really basically to prepare you. This is lesson 6, right, of Saxon, and unusually, unusual to Saxon, it's really only on one thing, which is adding signed numbers, which is great because we can look at it more deeply. What I presented to you yesterday was just like the tip of the iceberg. This stuff is actually really, really simple. However, I have friends that teach high school math. You know, they teach Algebra 1, Algebra 2, pre-calculus and whatever. And consistently I ask them, what are the things that people struggle with the most, that you are so frustrated with because they just don't get it really well? And one of the things she says is adding and subtracting signed numbers. This is one of the big things that you get. If you get this down really well, you're going to be so far ahead of other people. Yes, Thorn.
Yeah, at my old school I learned this, and like every day we would do a little test for these, and you'd get like a little sticky note, and you have to write down 3 answers like to this.
Yeah.
Yeah, it's pretty easy.
It is. It is really easy. But if it's only easy if you understand certain things, right? So we're going to talk about really easy first, and then we're going to move into really hard and realize how really easy the really hard ones are, right? But you can't always easily use the method I'm about to show you on the hard ones. That's why we're going to start easy, and then we're going to say, wait a minute, we're going to have to find another method, right, that's going to work. Okay, so first of all, if I said -6 plus a +2, I know this is easy, right? I know you guys all know the answer already, but just in case, let's go with it. You always start at 0. I'm just going to go up a little ways, and it says I go to -6, so -1, -2, -3, -4, -5, -6. There we go. I'm right there. But then I have to add 2. So from here, I've got to go which way to add 2?
Right.
To go +2, I got to go to the right. So I'm going to go over 2 and to the right. So this is where I end up, which is what? It's -4, right? So this should be -4. Does that make sense?
Yes.
Rebecca, are you seeing how I use this number line now? I basically start at 0, and I go over to -6. Or I go -6 places, 1, 2, 3, 4, 5, 6, which is -6. And then I'm going to, from there, I'm going to go to the right 2. So when they're negative, I go left. How do I write this? Negative, I go left. And when they're positive, I go right. Does that make sense on this thing? So it's negative, I went left to -6, and then +2, I go to the right 2, and then I see, well, where does that leave me? I'm at -4. So my answer is -4.
I just thought I was writing
Oh, okay. Victoria.
So I was just thinking about this because at my old school, we had this little song that was about the
Oh, cool.
sign numbers of same sign, add and keep, different sign subtract, take the higher, the sign of the higher number, that'll be exact. So like -6
That's
plus
awesome.
+2, you'd have to subtract it.
Right.
It's a different sign, and then 6 is the highest number, so you keep the negatives.
Right.
For the answer.
Right. So we're gonna that's exactly where we're going, and so we're gonna get there in just a few minutes. So you can, if I don't say it quite right, help me, okay? Because that's awesome. That's awesome. So now, sometimes though you don't see them written like this. You might see something written like this: -5 plus 7 minus 3 plus 2. Okay? I actually prefer it written like this without the parentheses, right? I much prefer this. However, you have to remember, you have to think of it in your brain sort of like this. That is a -5, and I'm adding to -5 a +7, and then I am adding, I'm not subtracting, I'm adding a -3, and I'm adding a 2. Does that make sense? That way I'm always adding, which means if I'm adding a negative number, I'm going this way. If I'm adding a positive number, I'm going that way. That make sense? So in your brain, you're thinking, okay, that's a negative 5 plus 7 plus a negative 3 plus 2. So let's try that one. Let's get rid of this. And we'll try this. So negative 5. So I'm going to come up here a little ways. I'm going to go negative 5. 1, 2, 3, 4, 5 right there. And then I'm going to go up just a little ways so I can... Oh, it says I'm going to do a positive 7. Positive 7 is that way. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So right, that's positive 7. And then it says a negative 3. From here I got to go 3 to the left. 1, 2, 3. Okay? And then I have to go positive 2. So 1, 2. Right there. What does that give me?
1.
That's a 1. Now, could we have done this in our brains? Right, we could have easily. Negative 5 plus 7 is negative 2, right? I'm sorry, no, sorry. Negative 5 plus 7 is 2. I was thinking it backwards. Negative 5 plus 7 is 2. 2 minus 3 is negative 1. Plus 2 is positive 1. So you can do it that way, you know. But this is what you're actually doing. You know, that number line is actually what you're doing. Okay, so are you clear so far that you have to think of it as negative 5 plus 7 plus a negative 3? You get that? You all understand that? That's kind of important to have that in your brain. Now, all right, now let's do another one. Let's do another one. Okay. Okay. Oh, wait. Oh, shoot. Negative 28. That means I got to go over. This is 10. This is another 10. I'm going to be over here. Oh, I don't want to be over here. What if it was negative 280 plus 13? Oh, my gosh. Right? Oh, my gosh. Right? It would. I don't want to use my number line. I don't want to write, 11, negative 11, 12. I don't want to go to negative 280, right? So I have to figure out a way to do this without using the number line with those little dots and things, right? Yes, Noah.
You could do, well, to get the answer to this, you could do 28 minus 13.
So we'll make it 28, negative 28.
Yeah, you do that, and you do 28 minus 13, which is 15, and then you take the sign of the higher number. Well, it's not higher number,
Right.
but
Okay,
the
so you
number
guys
that
know that.
has the most distance to 0,
Mhm.
and then you put it there. So it's it would be 15, and then you make it negative 15, and that's your answer.
That is correct. So the answer is negative 15. Now, so I'm going to just erase this for a second, including this mess I just made. And we're going to just sort of look at something for just a second. Because I'm going to explain what Noah just explained, okay? But, all right, let's try this. What if I said, I'm looking, as mathematicians, everything that's been learned in mathematics has been learned through observation and trial and error, right? And it's based, and all of this stuff is useful. The only reason we have figured some of this stuff out is because it's actually useful in some way in life. So we're going to be sort of investigators right now and just sort of look for patterns. All right. So let's say I had this. Let's say I had 10 minus 6. What would that equal? 4. Now look at this is very interesting. What is 6 minus 10? They're the same things, only I flipped them. Do you see that? What's the answer? Negative 4. Wow, that's interesting. That's a really interesting pattern. I'm noticing 10 minus 6 is 4, but 6 minus 10, just by flipping it, it's still the same number, only it's the opposite. It's negative 4. Okay, let's try this. Let's try 16 minus 12. What does that equal? 4. That's interesting. Okay, let's try it in reverse. Let's try 12 minus 16. -4. Oh my gosh, this is amazing. Oh my god, I'm starting to see a pattern. You seen the pattern? Let's try another one. Let's try 26 minus 22. What do you got? 4. Oh my gosh, are you seeing this pattern? This is amazing. Now we got 22. Let's try flipping them. 22 minus 26 equals -4. Oh my gosh, I have figured out this amazing pattern. Whenever I subtract one number from another number, it's either 4 or -4.
Yeah.
Right?
No.
Right? That's the pattern. What do you mean no? Look at the pattern.
Yes.
That's the pattern.
Perfect sense.
What?
Makes perfect sense.
It makes perfect sense. Now there's the man that I like. You know, he's going to get an A in my yeah, okay. So, all right. What's wrong with my reasoning? Yes, Mara.
All of them are numbers that if you subtract either way, they're still going to be 4,
Right?
positive or negative.
So give me an example of something where I'm wrong.
Uh,
Prove to me I'm wrong. Give me another something to do.
9,
What?
9 minus 4.
9 minus 4. Oh, that's easy. I know it's going to be 4. Oh, wait.
No.
Oh my gosh. Oh,
Wow.
4.
I can't
Minus
believe you
9.
destroyed my theory. All right, now let's try 4 minus 9. It's -5. So what is the pattern that we actually are seeing? Okay, Ma.
It's either when you subtract it either ways, it's either a negative or a positive.
Yeah,
But
it's
it's still
either a
gonna be the
negative or
same
positive, but the number itself is exactly the same. Now, how could that be useful? How could that be useful? So let's try them harder. Let's try harder ones. Let's try some harder ones. Let's say we have 48 minus 20, right? What would that be? 28?
No. Wait.
18.
28.
28.
No, 28.
28. All right, what is 20 minus 48?
-28.
It's -28. All right, now what if I gave you this problem? What is 25 minus 62? Yeah, immediately say, oh my gosh. Is it going to be positive or negative? Is everybody agreeing with me? It's going to be negative. So I'm going to immediately put a negative sign there. And I know, though, that if it doesn't matter which one I subtract from which, I'm going to still get the same number. Does that make sense?
Yeah.
So I can just do this, take the smaller number away from the larger number. That's so much easier than trying to do this. I mean, I would have a hard time going 25 minus 62.
37.
Let's see, carry the, there's nothing to carry. Oh, shoot, right? That's hard. But if I did it the other way around, 62 minus 25, that's pretty easy.
-37.
That becomes a 5, that's 12,
Negative 30.
that's 7, and that's 3. So it's going to be -37. Does that make sense? So I immediately see, I know, because I'm logical, I know it's going to be negative, right? I'm taking a tiny number and I'm subtracting a huge number from it. It's got to be negative, right? It's got to be below 0. So I put my negative, and then I just subtract the tinier number from the bigger number. Just like you've been doing for like 5 years, right? It's pretty easy. Okay, so
Wait, don't erase it.
so this is like really useful. It's really useful. That number doesn't matter which way we subtract. The number's the same. The sign is the only thing that's different. Now, Victoria said a couple things, and Noah echoed that as well. When the signs are the same. So now we're going to write down some rules that work. Okay? So this is all for just adding, when adding, okay? For adding. If the signs are the same, keep the sign. and add the numbers. So let's try that. So 4 plus 6. Are the signs the same? That's a positive 4 and that's a positive 6. So I'm going to keep the sign. It's going to be a positive something, right? And I'm just going to add the numbers. 4 plus 6 is 10. But if I had negative 4 plus negative 6, the signs are the same. The signs are the same. I'm going to keep the sign, and I'm just going to add 4 plus 6 is 10. So it's going to be negative 10. All right? So those are examples of this rule. Does that make sense? You guys all got that? And it makes sense. The way I use the number line, though, I still use the number line a lot with these, but I don't do it, I don't write it out. I use it in my brain. I start going like this. I say, okay, here's 0. 4 plus 6. Isn't that clear? Look, 4 plus 6. Everybody look at me for a second. I know you're writing, but watch this for a second. 4 plus 6. Isn't that obvious that I'm adding them? Isn't that obvious? 4 plus 6? I'm adding them, so it's going to be positive 10. What if I did this? Negative 4 minus 6. Isn't that obvious? I'm adding them again? Negative 4 minus 6. So in my brain, I'm often doing that. And then if I do negative 6 plus 2, negative 6 plus 2, I know as soon as I have to change directions, I know I'm going to start subtracting. Right? Does that make sense? But when I'm going in the same direction, I'm always adding. Right? Okay, so now that's the first rule. The second rule is if the signs are different, right? If the signs are different, if the signs are different, what?
Sign of the bigger number.
Yes, keep the sign. I'm not gonna write it technically correct, but keep the sign of the bigger number. I really should say it differently, but I'm gonna say it this way because this is the easier way to just. I'm trying to keep it simple, right? And I should be saying the sign of the bigger absolute value is what I should be saying, but it's like. You know what I mean? It's like that's technically correct, but I'm just going to say the bigger number, and that's really wrong, but I understand that, but that's okay. It's like I'm a teacher, I get to do that. And as long as I get the right answer, it works, okay? If the signs are different, keep the sign of the bigger number and subtract what? Subtract the littler number from the bigger number. Subtract littler number from bigger number. I'll give you a second to write that down.
Isn't it when you get into subtraction, it gets a little bit more confusing because the two negative signs will cross out and then it usually becomes a positive number? Well,
So-
what I learned is that two
but
negative
when you have
signs,
two
because it means
negatives,
opposite of,
but that's for multiplying,
oh, that's for multiplying.
right? That's the thing, is that this is adding, and when we move into multiplying, probably like tomorrow, you have to forget all these rules because it's totally different. And that's the problem, is people know that multiplying rule, negative times negative equals positive, or they think of it as like two negatives equal positive, so they say, oh, well, negative 4 and negative 6 is positive 10. No, that's not right. Negative 4 times negative 6 would be positive 24.
Yeah.
But negative 4 plus negative 6 is negative 10, right?
Also,
yes.
what I learned is like if you see like 4 minus negative 4 minus negative 4.
0.
But how I looked at it is like Matt told us something about this, where it's like you don't see the parentheses, and if it's just two negative signs next to each other, they become a positive.
Yes. So that's fine. That's good. So whenever you see two negatives next to each other, they automatically become a positive. That sort of goes with the multiplying. You'll see that. We'll talk about that in the multiplying. For now, I'm only talking about adding signed numbers today, right? And then when we talk about subtracting signed numbers, you have to, if you're subtracting a negative, you're actually adding, and we'll explain why, maybe tomorrow. But I can't remember where Saxon does it. I think it's tomorrow, but I'm not sure. But so examples of this: if the signs are different, keep the sign of the bigger number. So let's say we have negative 16 plus 12. All right. Now technically, negative 16 is not the bigger number. Technically, negative 16 is the smaller number, right? So that's why I'm wrong the way I wrote this. But I'm only talking about just the number itself, right? The 16, right? If 16 is bigger than 12, I look at the sign in front of the 12, the 16, and it's negative, right? The signs are different. If the signs are different, that's a negative, that's a positive. 16 is bigger than 12, the sign in front of the 16 is a negative. So my answer is definitely going to be negative, right? You with me? Does that make sense? And then I am merely going to subtract the littler number from the bigger number. 12 from 16 is 4. So it's negative 4. There's that 4 again. That's amazing. Can't believe you guys blew my theory. I was like, brilliant. I was going to become like Pulitzer Prize winner or something. Ah! Thanks a lot, you guys. Okay, so does that make sense though? Now technically I should say keep the sign of the number with the bigger absolute value. Because think about it, the absolute value of negative 16 is 16, right? The absolute value of 12 is 12. 16 is bigger than 12. That's what I should say. But just in real life, I don't say it that way. When I'm doing it fast, I'm thinking, okay, which is bigger, 16 or 12? 16, okay, keep the negative, right? And then 16 minus 12 is 4, negative 4, right? You see what I mean? You see what I'm saying? Okay, so that's basically it. So, if I gave you this problem, can I erase all this?
Yeah.
Yes.
Okay, if I gave you this problem, do it in your notes and tell me the answer. 420 minus 836.
That's 837.
How many? Raise your hand if you're done when you get there, just so I know. All right, so what did you get, Hayden?
I got negative 416.
Yep.
Negative 416? Is
Yeah.
that what you got, Rebecca? Is that what you got, Lucinda? Is that what you got? Negative 416. The signs are different. We're going to keep the sign of the bigger number, so it's going to be negative, and then we're just going to subtract the smaller from the bigger, right?
Yeah,
so
that's it, I
it just becomes 4164, negative 416. Beautiful. What about this one? Here we go. Negative 333 minus 222. Very good. The signs are the same, right? So here's my 0. In my brain, I do this. Negative 333 minus 222. Oh, I'm adding them. And they're going to be minus, right? All right, what did you get, Weston?
Negative 555.
Yes! It equals negative 555. When the signs are the same, you keep that same sign. It's negative. And then you just add the numbers. Okay, what about this one? We still have time? Okay, I guess we don't have time. I should probably tell you what the homework is. So homework is... Homework is, let me think.
Just read lesson 6.
Read lesson 6. And then, where am I? Lesson 6. On page pages 32 to 33. Do practice A through D. Practice A through D. And problem set. What? D, as in dog. Problem set. Five. Numbers 5 through 27. Is that too many?
Yes.
Well, that's only.
That's a lot.
Well, yeah,
Wait,
that
is
is
it just
okay.
these problems?
So hang on. So 5 through 19, and then I just want you to do one of these. So do number 28. Okay, is that clear? And then there will be a short quiz tomorrow, and then something bigger on